let's talk about that assignment. Let's go through it. What page were we on? 316. Thank you. 316. All right. What was the first one I gave you? Number 7. Okay. Determine the vertical asymptotes for the graph of the function. So vertical asymptotes take place when? When do the vertical asymptotes take place? Denominator 0. So what is the vertical asymptote of this? Yep. So vertical asymptote is going to be 0. So basically this graph there's our vertical asymptote. So what is this graph going to look like? It's going to approach it somehow. Usually it leans into it a certain way. Things that you could think about on this problem about how the graph would work would be, if I were to take -10 and plug it in, I would get 1 over 100. So if this is 1 right here, 1 over 100 is like down here. If I were to say take 10 and plug it in, or let's I already did 10. Or -10. Let's do -5. So that's going to be 1 over. So if this is -10, this is -5. So we're coming up a little bit more. If I were to plug in, say 1 in, I'd get 1 over 1. So then all of a sudden we're coming up. So this graph is doing this from this side. What do you suppose it's doing on the other side? Why am I not getting any negative numbers down here, though, in this graph? So there's a horizontal asymptote on this as well? Okay. So the vertical asymptote is going to be where the denominator is 0. The horizontal asymptote, it didn't ask to find it, but the horizontal asymptote being the degree on top, which is really x to the 0, and anything raised to the 0 power is 1. So x to the 0 is going to be less than x to the second, so the horizontal asymptote will also be 0. So this has 2 asymptotes, and that's basically what your graph's going to look like. What's going to be the difference between a hole and an asymptote? If this had a hole, what would the graph look different? If the y-axis was the hole, what would the graph look like in comparison to what it looks like now? What's the difference between a hole and a graph and an asymptote? Does a hole have the graph like go spiking up or down, or does it just jump over it? Yeah. Right. The hole is just you nailed it. It's just a point. It's a hole is one of the points where the graph won't exist. So the graph will draw right up to it, and then it's like it actually jumps over it. Okay. And an asymptote is going to go. It's going to be a vertical line or a horizontal line that the graph can go along. It'll approach it. It'll never reach it. So things like that. What was the next number I gave you on these problems? 11. So number 11, we have function at x is equal to 3 minus x over x minus 4, x plus 6. Okay? What are you guys dinging, or is that my fault? Did you guys find out my cat?
What's the string on your phone?
Huh? So I can hold on my wrist.
No phones at school.
You don't have that.
But it's from the director of schools of Cherry Creek School District. What's his name? Something about make sure all your kids have their phones away.
Do they have cameras in classrooms?
Yep. Yeah, there's
No,
one
they
on that.
can't have cameras inside. They have cameras.
Wow.
That's actually a true thing. No, they don't have cameras inside classrooms because you're being watched by your teacher, so like you're supervised there, but in the hallways.
She just told me that. So if the teacher leaves the room, then are they able to?
So then they have to
Yeah.
No, I'm
It's
just
like,
saying
maybe
they
not
don't.
make sense.
But there's not a need to have a camera in here because
No, it's really?
It's illegal.
Do
Do you know why the girls' bathrooms are closed? It's because they're installing cameras.
Alright.
I'm just blowing
On
it
that
down.
note, I'm gonna work on this.
I'm just kidding. I was just trying to.
That's pretty funny.
It's creepy because it says close until further notice.
Exactly.
It says close.
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 Close until further notice.
Close until further notice.
That's coming from a math
Don't
teacher.
say that.
I even saw that grammatical error as a math teacher. Come on.
Oh.
Alright, here we go. Does this, by looking at it, obviously it's reduced down to binomials. Does this graph have a hole? How do you know if it doesn't? So the binomial has to match on top and on bottom to have a hole. That's the first thing. Okay? So I don't have a hole on this problem because a binomial on top is not matching a binomial on bottom. So the vertical asymptote is where the denominator is equal to 0. So the vertical asymptote is where the denominator is equal to 0. So what values would make our denominator equal to 0 right now? 4 and what? 4 and -6. Okay? So those are vertical lines that are drawn. How would you represent the domain if you knew that you couldn't have those two values, but everything else would work? Negative infinity to -6? Yeah, and there you go. That's how, if we did ask you, hey, what's the domain of this going to be? That's how you'd have to list it. That means all of the negative values all the way up to -6 work. All the numbers that are between -6 and 4 work. And all the numbers bigger than -4 work. Notice they're all rounded brackets because they're approaching them, but they don't reach them. Okay? Now, we're not going to necessarily, I just wanted you to see that so you had some reference as far as, we've been talking about the domain quite a bit, but I'm not going to worry about it for right now. All right, so we have vertical asymptotes at both 4 and -6. Now, here's a hard one sometimes. What is our degree on top? 1. What would our degree on bottom be? 2. Why 2? Right, if I were to FOIL the binomial on bottom together, I'd have x squared on bottom. I have x to the first on top. So if my degree on top is large or smaller than my degree on bottom, what is my horizontal asymptote? Huh? 0. Good. Okay, so let's draw in what we know. Here's my xy axis using our crayon function. I don't know, I just like the crayon. So I'm going to draw my vertical. So at 4, 1, 2, 3, 4. At -6. And then the horizontal asymptote is going to be at 0. Ooh. Anybody have any ideas what this graph might look like? Or how we could kind of think about what it'll look like? Okay, so let's pick. Yes. 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 You nailed it. Okay? So what Liddy said is absolutely right. What's going to happen is we have like a parabola looking in between the two blues, and then it's going to kind of look like I guess almost like a hyperbola outside of it. Huh? A wiggle?
That's what it is.
So, well, let's think about this. If I were to take... Wait till we get to the triangle, we're doing the sine curve or the cosine curve.
Oh, yep. There it is.
And then the tangent here. I'll do it once. Not come back.
People just like hold our hands.
the Royal Testing Store. If I were to take 10, the number 10, and plug it in, on top I get 3 minus 10, which is negative 7, yes? And if I were to plug 10 on the bottom, I'd get 6. I'd get 6 times 16, which would be... So we'd actually, at 10, way out of 10, we're actually getting a point way out here. So this graph is going to kind of look like this. Can I do that right? Nope, no. Close your eyes. You didn't see that. Shh. If I were to plug 10 in, on top I'm going to get negative 7. On bottom, you guys are being rude. What am I doing wrong?
Do we have a story today?
You guys are over here talking, being rude. All right, is that going to be a negative or positive value? Negative. So this is down here. So if I were to take, say, negative 10, which is out here, and plug it in, do you think I'll have a positive or a negative value? Let's see. Take negative 10, plug it in. That becomes 13 on top. And on bottom, I'm going to get, negative 14 and negative 4. Multiply that together. Will that be positive or negative? Did I right? Negative 10, negative 10. Oops. Wait. 10, negative 14. Okay. Negative or positive?
3 minus 10.
Where did I get that? So if I take negative 10 and that becomes 3 minus 10, which is 13, right? And then I get negative 14 and negative 4. So that's positive on top, negative on bottom, negative on bottom. So is that positive or negative? It's positive, so it's above this gold. So that means this is going to kind of look like this. What's going to happen in the middle? Let's pick 0, plug it in. So let's pick 0 and think about what 0 is going to do. 3 minus 0 is 3. 0 minus 4 is negative 4. 0 plus 6 is 6. Is that positive or negative? Negative, so that's somewhere down here. Okay? And I think once we see this graph, we're going to see what it does nicely. It actually kind of looks, if you take a trick, kind of looks like a tangent graph, I'd say. If I were to take 1 and plug it in, if I plug 1 in, I get 3 minus, if I plug 1 in, I get 3 minus 1, that's 2. Negative 3. And 7. Is that positive or negative? Negative, so that's down here. What if I plug negative 1 in? 3 minus 1, that's minus 1 is 4. That's going to be negative 5. Positive 5. Positive or negative? That's basically what that graph's going to look like. Okay, am I going to have you reproduce that kind of graph, that complex on the test? No. But I just wanted to see how we're going through it. We're just trying to get an idea where the graph's existing. Basically, things that you need to see on this is you have these regions of all places the graph could exist. So you just pick numbers that are kind of outside of what the asymptotes are or even inside to get a basic idea of the shape. What was the next problem we had? 15? Okay. 15, determine the horizontal asymptote of the graph. Okay, degree on top is equal to degree on bottom. What's my horizontal asymptote? 3 over 4. So, I'm not going to graph the whole thing, but basically, this is 1. Then we're going to have at 3/4 our horizontal asymptote. Okay, so the degree on top is equal to degree on bottom. You take the lead coefficient of the highest exponents, put them over each other. If there's not a number there, the number that is secretly there is 1. That's all we have to do with that one. What else do we have to do? Which next? 19. I give you every other odd? Okay. G at x is equal to x to the third minus 2x squared plus x squared. or plus x minus 1. Okay. If my degree on top is larger than my degree on bottom, do I have a horizontal asymptote? If my degree on top is bigger than my degree on bottom, do I have a horizontal asymptote? No. So horizontal asymptote? No. Does this have oblique asymptote, which is end behavior? Yes. How do I find it, though? How do I find the end behavior asymptote to this problem? We worked on it last week. Before synthetic division. The long division. Okay? You don't need... Now, the nice thing about when you do this, you don't have to worry about the remainder. You're just looking at what you're dividing everything by. So you're going to use the long division on this. So I have x squared minus 16 into x to the third minus 2x squared plus x minus 1. So what do you have to multiply times x to get x, or x to the second to get x to the third? X. So that's going to be x to the third minus 16x. You're subtracting. So those cancel. Minus 2x squared comes down. Negative 16, that'd be negative, negative, positive, so that's plus 17x. Okay, what do you have to multiply times x squared to get negative 2x squared? Negative 2. And then, so that's going to give me negative 2x squared minus, or plus 32, excuse me. So I know that once these cancel out, I'm going to get 17x, 18x, excuse me, because it's combining with that, plus 32, minus 30, minus 33. Is there anything I can multiply times x squared to get to x? I'm not worried about the remainder. This is my end behavior asymptote. What kind of graph would x minus 2 look like if I graphed it? A what? A line, straight line, good. So, just to give you a picture of what's going on with the end behavior, y equals x minus 2 is the end behavior asymptote. So, if you had negative 2, and then you go up 1, right 1, if you had this line drawn, this particular graph, as far as the ends go, so as far as over here goes, and down here, that's what the end behavior of the graph is going to do. So as my function at x approaches infinity, so goes right, as x goes to infinity to the right, my function at x continues to go up. So as x approaches infinity, then function at x also approaches infinity. That's my end behavior. And what is this end behavior? How would I write this one? As x approaches what? Negative infinity. Then the function of x approaches negative infinity. So the end behavior asymptote talks about where the ends of the graph will be going. This case, it'll be the linear equation that our graph at the ends will approach to touch, won't necessarily touch it. Okay? So if we don't have a horizontal asymptote, then it should have an oblique or an end behavior asymptote, and how you find it is doing long division. Do we have any more problems?
Yeah.
Oh, 23.
23? Okay. Yeah. Yes. And then this one just says, determine the oblique asymptote. How do you know it has an oblique asymptote? Which asymptote's missing? Horizontal. Could it have a vertical asymptote? Yeah. Anyone know what the vertical asymptote up here would be? Nailed it. So vertical asymptote And then oblique is going to be x to the third plus 1. Shh. Come on, guys and girls. What am I doing wrong?
Teaching.
What do I have to multiply times x in order to get x to the fourth? So I'm going to get, oops, this should be x to the fourth. Sorry about that. That cancels. Plus x minus 2. I can't multiply anything like that. So that's just a 45-degree line coming right through the origin. How do you feel about those?
Pretty good.
We doing all right?
Don't we do gonna try?
Well, I was going to add to it now. So yesterday I gave you, tell me what yesterday's assignment was.
17 through 25, every other odd.
So you had 17 through 25, every other odd. How about we do 8 through 24, every other even, and that's what I will mark off tomorrow. What page is it?
316.
Page 316.
Can we start
So
now?
I'd like to have both of them on the same page. Yes, you can have multiple pages, but please, by all means, take this opportunity. I will tell you that tomorrow we will start a review. I have a review packet to hand out to you. That will also be on Friday. Okay? And then Monday, Tuesday, guys and girls, I'm going to tell you this. This is my chapter, so I want you guys to do the best on this test because this is my chapter I put together. That way it makes me look like, an awesome teacher. I have to look like an awesome teacher at least once this year.